Benjamin Franklin was the first scientist to study the Gulf Stream current, producing one of the original maps of what he described as the river of warm water in the Atlantic. The work of Wallace Broecker continued the Franklin legacy, but went beyond charting the oceans to revealing the powerful influence they have on climate throughout the Earth's past and into the future. Growing up in Chicago, Wallace Broecker was like lots of other kids, more interested in his hometown White Sox than his textbooks.
To tell you the truth, I had almost zero intellectual interest.
But that changed in college when Broecker was assigned a big brother named Paul Gast, a geochemist who was working at Columbia University's Lamont Observatory.
He asked me what I was going to do, and I told him that I was going to become an actuary. And he said, "Oh my God, that's really boring."
When Gast got him a summer job at Lamont in 1952, Broecker's indifference turned into a passion so fierce that he was quickly put in charge of one of the first labs to trace the movement of ocean water using radioactive carbon dating.
So it was a way to sort of constrain how rapidly the deep ocean was, we call it ventilated, flushed by water descending from the polar regions.
He stayed to earn his Ph.D. and in 1959 joined the Columbia faculty. Broecker pioneered a new way to reconstruct past climate changes by dating ocean and lake sediments. His discovery that the last ice age ended abruptly convinced him that major climate shifts could occur very rapidly. In fact, he and others found that ocean climates changed abruptly many times in the past.
The original thing that was found was that the ventilation time of the Atlantic Ocean, the deep water, was replaced on time scale 1 or 2 centuries, whereas in the Pacific and Indian Ocean are more remote. The deep waters there were replaced more or less once every 1,000 years.
But researchers found no evidence for what could trigger such short-term changes, only gradual shifts that nudge the climate one way or another.
Was the first one to put my finger on the fact that the Earth's climate system is in a sense quantized and it can jump from one state of operation to another. There must be great amplifiers operating in the system that can make small nudges into large pushes.
Overlaying the ocean's currents over time with a history of global climate, he realized the ocean itself triggered the changes.
It occurred to me that the way the Atlantic worked, which is bringing warm water to the north in the upper ocean, then it gets cooled in the winter, sinks, and then flows south, that if you turn that off, that would make a big climate change.
What's now known as Broecker's conveyor is the mechanism behind stable climates. Turn off the conveyor and climate changes abruptly.
The planet hasn't been much warmer than it is now for 1 million years. So therefore, we're going into unknown territory.
Man-made CO2 is now warming the planet at a steady rate, and Broecker worries about the consequences.
I got the idea that it's like an angry climate beast, and if you nudge it, you get an overreaction, like some people would say. And some days I'm like that.
He may joke about it, but Broecker calculates that even if alternative energy and conservation are widely adopted, atmospheric CO2 will still surely double with unknown consequences.
The Earth system has the capability of jumping from one way of operating to another, and that would be a bad thing if we were to trigger that by adding CO2 to the atmosphere. We've got to do more than just have goodwill toward cutting down on fuel use using alternate energy. It's going to take something else, and that something else is not developed.
The 2008 Benjamin Franklin Medal in Earth and Environmental Science is presented to Wallace Broecker for pioneering research leading to an understanding of the ocean's influence on climate change. His work led to the successful development of a comprehensive picture of ocean circulation and its role in both past and future environmental change.